two student minds grew out to a student team of 50 people working on a common goal. We've moved more than 7 times, adjusted plans more than 100 times, and faced challenges an uncountable amount of times. But throughout these 3 years, one thing has always remained the same: the deep desire for progress towards a better future. You see, as a student, one finds themselves in a maze of theory. A student is often faced with questions like, what am I doing all of this for? What am I learning all of this for? And the answer to those questions is that the theory fits into the bigger picture. But what bigger picture? Is there even a bigger picture? Whether there is a bigger picture or not, what we do know is that how we've been living in the past is not how we can continue living forever. We know what we must do to ensure our future well-being: cut our environmental footprint. Sounds easy, right? And aviation has always been on the forefront of innovation and of the highest possible tech. It's the industry that makes people dream of faraway destinations, of soaring above the clouds, and of freedom. In recent times, these dreams have made place for a sad realization. A sense of shame, justified shame, has been cast over flight. Fueled by cognitive dissonance, we've tried to ignore the environmental problems flying causes for as long as possible. But these problems are catching up to us. Where aviation has been treated as a special child and has enjoyed almost no carbon restrictions, other industries have had to adapt. Aviation has been surpassed by the automotive industry in terms of developments towards sustainable operations. Driving from Amsterdam to London is easily possible in a carbon-neutral way these days, but flying across the pond without any emissions is far from possible. It's time we step it up and start caring about our future. And this is where our desire for progress towards a better future comes in. Today, we want to show you where our developments stand and how close we are to those first emission-free flights across the pond. The bigger picture might seem vague, but at AeroDelft, our goals with Project Phoenix are clear: clean skies. Hi there, my name is Jan Willem. I'm AeroDelft's team manager and I'll be your host today. I would like to welcome all of our online guests watching the YouTube stream, but also our audience here that we're lucky to have in real life actually for the first time. And we're thrilled to show you all of the progress that we've been making over the past year. Let's kick things off with a video of our partners showcasing how they've been helping us throughout these 3 years, and especially throughout this year. So let's roll it.
My name is Christophe de Smet. I'm the CEO of AeroDelft and HR, a Belgium-based company specialized in temporary labor, currently the number 5 on the Belgian market. We decided to support AeroDelft because we all believe it's very important that we have cleaner skies, because we all want to keep our way of living, our current footprint, but we want to do it in a CO2 more neutral way. Do I see hydrogen as the future? Very difficult for me to predict, but I'm pretty sure that it will be one of the more important fuels where this world will run on, besides all the others like electricity, like wind, like the powers of nature. I really do believe it's important to invest in innovative aviation, because aviation, as I said, traveling, flying, is in our genes, and if you can do this in a more environmental friendly way, I think that matters for us, but also for the generations to come.
Well, the Royal Netherlands Aerospace Centre is an ambitious knowledge organization for more than 100 years. 2 years ago, we became a Royal, and we try to contribute to make aerospace more sustainable, more efficient, more effective, and of course, safer. Well, I think testing is the key thing. If you're not able to test, you can't improve your system, you can't improve the processes. And of course, well, the main thing is, I think, you will learn of your failures. And if you're not making failures, you won't learn. So testing is key. And it's not just one time, testing, testing, testing.
My name is Henry Beery and I'm the Dean of the Faculty of Aerospace Engineering at Delft University of Technology. Being a university and being a Faculty of Aerospace Engineering, our main focus, of course, is to educate new students, bring them the right knowledge, the right, let's say, mindset, DNA, and of course we want to do the state-of-the-art research, and we want to have impact on aerospace worldwide. Try new things, try risky things. I'm not talking about safety, but let's say technically a bit risky, and you bring parties together. And I think this is something which is really wonderful about what AeroDelft is doing as well. You bring together students, people from our faculty, but also industry. Actually, you bring all of the ecosystem together, and it's just like what we are doing in our Aerospace Innovation Hub over here.
Aerospace Coatings is a small part of that whole big company. We develop coatings for all different segments in the aerospace industry. That means the exterior of a coating of an aircraft. It means also the structure of an aircraft. There the focus will be corrosion protection. It also is the cabin coating, so the area, the surfaces you see when you're sitting inside the aircraft. It's all coated by AkzoNobel coatings, or at least it can be coated by AkzoNobel coatings. Young people who are maybe sometimes a little bit naive, but also open for many, many different ideas. And we are not stuck to the framework of the big OEMs like Airbus or Boeing, but we could just work with these guys and with this team just to see, okay, what is possible in order to get the nicest result.
We are AeroDelft and we are producing innovative products for all kinds of liquid gases. And our main focus is in the helium and in the liquid hydrogen systems.
Hydrogen has some particular risks, and that is it explodes quite easy. But as long as you keep it contained, the risks are really very low. But you have to observe certain measures, some extra measures towards the standard fuels like gasoline or kerosene. But once you do that, it's a safe fuel. It's not more unsafe or less safe than gasoline.
Rotterdam The Hague Innovation Airport is an innovation platform for sustainable aviation. For sustainable aviation, it's very, very important to continuously innovate. Yes, one of our iconic projects is SAF, Synthetic Aviation Fuels. Our partners within RIA, the airport, Zenit, Sky Energy, Uniper, they try to realize a demonstration plant for synthetic aviation fuels which are circular.
We are an aircraft leasing company in the sense that what we do is we manage aircraft for investors that seek to find an acceptable return by investing in aircraft that are leased to these airlines. It can't go on like this, and so there's I guess a human desire to do something good for humanity. As we can at least see it now, it looks like hydrogen-powered aircraft are the future. So for me and my investor base, it's important to know, will this happen 10 years from now, 15, 20 years from now, or 30 years from now? Because the sooner it happens, the more of a threat it becomes to existing investments, and the more of an opportunity it becomes for future investments. So it's essential for us in that sense as well.
LVH Advocaten is a Rotterdam law firm with focus on entrepreneurs. We are therefore specialized in corporate law
and all kinds of legal matters that a company can encounter. With this admirable goal of having emission-free aviation, we really like to support that goal and strive to a cleaner sky and better world. And with our contribution, we hope to help with that initiative.
We are a consulting firm focusing on company-wide transformations on the field of customer experience, agile, value creation, operational excellence, and organizational design. Working with different backgrounds ensures we have different perspectives on the complex kind of problems we're solving in projects, And this way we can come up with more innovative solutions and challenge our clients and ourselves to well, be holistic and really come up with something which helps the clients on their way to a better future.
TNO is Applied Scientific Research Organization of the Netherlands, and it is right now more than 3,000 people, and some small portion is the staff. The rest of them are actually the researchers and looking into different aspects of sustainable future. Where is the cheap renewable energy? So you need to think about North Africa with continuous, like 11 months of the year, solar energy, North Sea with the continuous wind. But how are we going to bring this renewable energy to more populated regions? And that's where liquid hydrogen starts to be one of the biggest players.
This year ADIZ exists 25 years, and in those 25 years we've been helping companies in the aerospace, the rail and defense industry on complex problems, technology, programs and innovations.
Well, hydrogen is new in the aviation world, so you don't have any to certify for. That's why you have to search for your own certification specifications. A kerosene fire is very different than a hydrogen fire. So you have to set up your own regulations, and that's, I think, the biggest problem or challenge with hydrogen.
We are Frisian Air, a Frisian company, importer of the South African sling for TSI, distributor for Europe. We are located at the Drachten airfield up in the north of the Netherlands. Frisian Air, we are already a long time involved in aviation. We are pilots, so we like to fly. We like to get aircrafts and aviation to the next level. And we have already a long history with importing other airplanes, and this is our new business model for the sling for TSI.
That's great to see how our partners have been helping us throughout these years, and honestly I can say without their help we wouldn't be standing here today. And a partner at AeroDelft is not just a partner on a website, not a logo on a website. We really work together with them, and without their support we wouldn't be able to do anything. So I'm very honored to be able to show their support to us. Let's look at the schedule for today. So the presentations will be done by Sam and Matthew about Phoenix Full Scale and Phoenix Prototype, showcasing all of the progress that we've been making throughout these years. Next to that, after that we'll have a quick break, after which the panel discussion on certification with guest speakers Henry Wery, Marijn Hogendoorn and Pieter Groskamp will be joined by our certification engineers Ole de Koning and Rehan Siddiqui and me as a moderator to discuss certification within our project. As last, we'll have the walkthrough of the Phoenix Full Scale done by Alex and Floris in virtual reality, so stay tuned for that at the end of this event. But now first, Sam, here's the clicker. To you the word. There you go.
Now let's go to my first slide. Oh, seems to be some issues. There we go. Perfect. Well, thank you for that wonderful introduction, Jan Willem. Hi, I'm Sam, Technical Manager of the Phoenix Prototype Project. We've had a great year here at AeroDelft, and we're going to have many great years to come. So please allow me to tell you all about that. So flying, it connects the world, but now we all know that it can be quite polluting. Now, even during vacation times, we would like to go off to faraway destinations, but sadly, many of us have to think twice about that. That shouldn't be a thing. That shouldn't be an issue. We should make a change. We need a revolution. That's where AeroDelft comes in. Revolution in aviation. Our mission, to prove and promote liquid hydrogen as an alternative to conventional fuels in aviation. Project Phoenix and its two sub-projects, Phoenix Full Scale and Phoenix Prototype, were created for this mission. We'll tell you about both of these projects today, but for now I will focus on the Phoenix Prototype. The mission statement for the Phoenix Prototype is to fly a scaled prototype with a liquid hydrogen propulsion system. So the Phoenix prototype, or PT for short, is a 1:3 scale E-Genius glider plane with a max takeoff weight of 50 kilograms. With a wingspan of 5.7 meters and a length of 2.7, although it's a drone, it's still a pretty big boy. Ultimately, she will be flying with 3 different propulsion configurations. First batteries, then gaseous hydrogen, and then finally liquid hydrogen. So here is a rough timeline of what we will be doing. Like I said, we're ultimately going to be flying, but that will be coming next year. In these past years, we've made great progress to be able to ultimately take to the skies. From the founding of the project, Project Phoenix, in 2019 to about a year ago, we consider to be the initiation and design phase of this project. Then, this past year, we consider it to be the production phase and also the subsystem testing phase. And next year, we will be entering the full system testing and flight testing phase. So like I said, this year was the production phase. Earlier this year, I had the honor to reveal to you the prototype aircraft. At that point, it looked beautiful, but it was not fully ready yet to take to the sky. We had major parts of the airframe, but it was not nearly at a point that we can take off. So since then, we have been taking big steps to be able to fly. Clicker looks a little weird. So regarding the structure, we've been making a lot of great progress. Much of the structure is now done. The wing is fully finalized, and a lot of the final components have been integrated into the structure. Now, the structure is nearly ready for us to be able to integrate all of the electronics control and propulsion systems. One of the most recent additions to the structure is the main landing gear. The landing gear is, of course, a very critical part if we want to ever be able to land, but also it's a very difficult thing to build. What you see here is our first iteration of the main landing gear. We thought that this would be strong enough, but clearly testing showed otherwise. It's a similar story for our tail landing gear. Here you see a drop test, and it flexed way more than it should have. But we don't see this as a failure, we see this as a learning moment. Like they said at the NLR, you need to test and test and test to be able to make a better product. So we went back to the drawing board, designed new landing gear, and ultimately we created this. Here you can see the new landing gear leg, which dwarfs the old landing gear leg. We really believe that the new landing gear legs will be able to take the force that they will need to. So now you can see right here next to me is the prototype aircraft. If you zoom out a little bit, you can see that the aircraft is, it looks quite similar to what it looked like when we first released it. But there's many different changes that have been made now. It looks quite similar, but it's now much closer to being ready to take to the sky. So in addition to all of the structures department progress, the electronics control department has also been making a lot of progress. We have most of our hardware done now. The motor is in, the electric speed controller, and also a lot of the circuit boards and wiring has been completed. We also recently built our cruise battery, which will be the main replacement for our battery-only flight for the fuel cell. But much of electronics and control development is designing these circuit boards and wiring diagrams and coding, and more coding. There's not a lot very interesting to show there visually, but ultimately that all culminates in tests such as what you see here. This is one of our servos tests. The servos will allow us to move the control surfaces of the aircraft from the ground. Tests like these are very valuable for us to understand how these systems work, make sure that they work well, and also prepare them for integration. We've also been doing a lot of extra testing at the electronic control department. Here you can see a photo from right before our prototype of prototype test. We dubbed it this because we are taking some of the control elements from our Phoenix prototype aircraft and putting in even smaller aircraft to test them. Tests don't always go exactly the way we want them to, but like I said, we learn from them, we improve, we continue, and ultimately we're able to take to the sky, as you can see here. This was some footage from this test, and this allows us to understand much better how these systems will work when we actually integrate them into the aircraft. We can make sure that the modes that we were working with and everything is up to par. Also recently, we had the chance to be able to start testing our motor. The motor is quite powerful, and at the testing, we were really interested to see how powerful this was. Also, tests like this allow us to get a feeling for the temperature that these get to, which is of course very important when we integrate it into an enclosed space. Ultimately, after that test, we integrated that into our aircraft. That was a really amazing moment, and really here you see the melding of the structures department and the electronics control department. So what we did here is we did some of our first taxiing tests. This really gets us a feeling for how the motor will function inside the aircraft once we will be taking off. But of course, these are still very basic tests, and it's a little scary to let our baby drive around by her own. That's why you see one of our engineers holding her hand. But soon, she'll have to do this all on her own, and much more, like flying in the sky. But luckily, we'll have a great pilot who will be guiding her along the way. In addition to all of the great progress that has been made regarding electronics and the structure, we've also been taking big steps regarding our hydrogen propulsion systems. We have two systems we're working on, our gaseous hydrogen system and our liquid hydrogen system. Regarding the gaseous hydrogen system, we have basically finalized the system. All of the electronics and the integration and also the components that allow all the components to work together are all now done. Also, we've been able to test the hydrogen propulsion system many times now. Specifically, the fuel cell has been run many times, and we are very comfortable with it. And also, thanks to our partner, the NLR, we've been able to run the full system outside of the aircraft, and we have now been able to reach maximum power of 1500 watts. Now, right here next to me, you can see the gaseous hydrogen system. Soon, after our battery-only flight testing, this system will be integrated into the aircraft and will serve as the main power source. We're very proud of the progress we've made here thus far. So then, our final step, liquid hydrogen propulsion. So the liquid hydrogen system has many complex pieces of machinery in there. The one main is, of course, the tank. Building a tank for liquid hydrogen is not very easy and requires a lot of precision. We have luckily now after some learning moments, we believe that we can now build this tank flawlessly. Also, the inlet to the tank, which is of course very important when you're working with liquid hydrogen, has now had its design finalized, and we will soon be able to begin production. Then there's also many support systems within the liquid hydrogen propulsion system. These systems require a lot of engineering work, and without them the system would not work. Here you can see two of these elements. First, you can see the valves assembly, which is a subsystem which will regulate the pressure of the hydrogen in the system. You can also see two images of the heat exchanger, which will heat up the very cold hydrogen in the system. These are some of the main elements of the hydrogen propulsion system, of course, including the fuel cell, which I already said we are very comfortable with. All these elements together will allow us to fly on liquid hydrogen. This really is a one-of-a-kind system, and we're very proud of the developments we've made here. This is really cutting-edge technology, if I say so myself. So ultimately, for all the things that I've talked about to be able to fly, we've been looking into certification. This is, of course, a very important thing. Certification includes documentation, safety analyses, registration, and testing, 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 in the famous words of the NLR. And later in this event, we will have a panel discussion in which you will learn more about what they do and the challenges they face. So that was a brief overview of the progress that we've made this year. So much was done by the amazing prototype engineers that I couldn't cover today in this short presentation. But for now, we focus on the future. This presentation, sadly, is a little, oh, this is perfect. I got some information that the presentation was old, but they fixed it, which is amazing from our technical staff. But so we look towards the future, like I said. We will be having 3 separate flight testing phases, as I discussed earlier. First, we will be flying on battery power. During this flight, we are really trying to test the electronics and make sure that our aircraft is a good testing bed for the future hydrogen propulsion systems. Then, the next phase is gaseous hydrogen. As I already showed, the gaseous hydrogen system is nearly ready and will be integrated into the aircraft after we complete our battery-only flight testing. This will mark AeroDelft's first gaseous hydrogen flight. Then, ultimately, we are working towards our liquid hydrogen flight. As I showed, the system is already very far in development, and we're hoping to finish that fifth system and start outside of the aircraft testing quite soon. It's still a little bit difficult to actually predict when this will happen because it's such cutting-edge technology, but at this point, we're aiming to be flight testing around this time next year. So there's a lot of work that needs to be done still to get there. But as you can see, we've done a lot of work this year and in the past years before then. So we are very quite confident that we will soon be able to take to the sky. Now, these renders that you see here are beautiful, but it'll be nothing compared to the feeling that all of AeroDelft will have when we finally are able to take off. I know that I personally will have little butterflies in my stomach at that point in time. So being able to ultimately flight test on liquid hydrogen will be an amazing step for aviation. Being able to use this small-scale demonstrator to learn about how liquid hydrogen functions inside an aircraft will allow us to take that forward to bigger future plans, which is exactly what we're planning to do. AeroDelft is not just stopping at this step, but we want to continue our fight towards sustainable aviation. So what's the way we could do that? Well, maybe scaling things up. How about a full-scale aircraft? Well, please welcome Matthew, who will tell you all about our ambitious future plans. Here you go, Matthew.
Indeed, Sam. Why not scale things up? This is exactly what Phoenix Full Scale is all about. My name is Matthew, and this past year I had the honor to kickstart this project as a technical manager together with a team of engineers in September 2020. Our aim is to convert an existing two-passenger aircraft into a hydrogen electric one. For this year, we're first going to fly this aircraft on gaseous hydrogen by 2023 and then on liquid hydrogen by 2025. For this year, our goal is to create a detailed design of our aircraft. But how did we get started with this exciting project? Let me explain it as follows. Imagine, I think we have some technical difficulties. Just hang on for a brief moment. All right. All right, we're almost there. Indeed. Oh, a bit more back. Thank you, Adrian. All right, so how did we get started with this? Imagine that you're making a puzzle like this one, and that you have to make the puzzle even more beautiful than it is by taking out all the standard puzzle pieces and creating new ones by yourself. This approach of taking apart a puzzle and creating new puzzle pieces is exactly what we engineers had to do with our aircraft. We had to find new cutting-edge technologies, components that actually fit our needs. But of course, it is that we can only start this puzzle when we have an aircraft selected. We need one in which we can easily integrate our components into. And for that, we did a feasibility study and extensive research because there's so many things to think about. And we decided to select this aircraft for a project. This is a Sling 4 jet aircraft. It has a maximum takeoff mass of 920 kilograms, a wingspan of about 10 meters, and it can transport 4 passengers, but we're converting it to a 2-passenger aircraft. Since it is a jet aircraft, we can build the aircraft by ourselves and modify it to our needs. But of course, it is really necessary to get started with exciting projects, and the very first thing that we did was mapping out our components. Here you see how we did that. Since we could convert the aircraft from 4-passenger to a 2-passenger aircraft, we created enough space for a hydrogen fuel tank and a fuel cell. Our fuel cell requires both hydrogen and air to produce electricity. And the air that is needed is supplied from the front of the aircraft, where you also have our batteries and electric motor located. Of course, it is time for us to move on and really get started with the work itself. For that, we started making connections with companies, because our aircraft can only fly on hydrogen with very advanced technologies and lightweight components. To put our needs into perspective, it is that our Phoenix prototype needs 1500 watts to take off, whereas our Phoenix Full Scale requires 100,000 watts of power just to take off, which is 60 times as powerful. But when you're looking for more power, you're also looking for more trouble. And this is something that we definitely experienced. Because our fuel cell system, this blue box that you see right here, was 170 kilograms, and it did not fit in our aircraft. We felt lost and thought by ourselves, how are we going to make this work? We decided to do what we engineers are good at, think outside of the box. We literally came to the conclusion to take apart this box, and so we did, together with PowerCell, which resulted in the following. All the hydrogen components were placed in our hydrogen area and isolated from the cabin with a very special wall called a firewall. Of course, to produce electricity, we need also air in the most perfect condition. Those components are placed in the front of the aircraft. But we also need hydrogen. So let's take a look at the next puzzle piece, which is our hydrogen tank. This is a tank that we selected. It is a tank that can store 1.25 kilograms of gaseous hydrogen under a pressure of 350 bars and has a total mass of 30 kilograms. Together with Luxfer, we are adapting it to the needs of a finished fuel scale. And once we created the electricity on board of the aircraft, we have to transfer it to our electric motors, but it needs to be adapted to a fuel cell system. For that, we got in touch with a Dutch startup called Saluti Motors, which is creating a very cutting-edge technology motor which can be adapted to a fuel cell. Together with another team in Delft that is creating an electric aircraft, we are actually integrating this electric powertrain together in the aircraft. However, let's take a look at how all these and many other puzzle pieces actually come together in our design. If we can play the video itself. So in our hydrogen area, you see the hydrogen tank and the fuel cell system. Oh, yeah, okay. Hydrogen tank and the heart of the fuel cell system, which is the fuel cell stack. This area is separated from the cockpit. In the front, we have our batteries, and together with the fuel cell, it powers our electric motor. But let's also have a look at the front of the aircraft. Here you see how all the engineering works falls perfectly into place. Later in the event, there will be a VR tour to give you some more insights into how this design actually looks like. However, the question still remains, is this all that we need for a hydrogen electric aircraft? The simple answer is no. We also need several safety systems on board of aircraft, and this has to do with that hydrogen is a very small particle. We need to make sure that if there's a possibility that it starts leaking, that we prevent this. And we do that by ventilating our hydrogen area with air, which looks as follows. Here you see that air comes in from the sides of the aircraft and blows out the hydrogen particles from the top. But what happens if the system does not work properly? There's a risk that hydrogen starts accumulating and a hydrogen flame starts, and this flame is not a normal flame, but is of a temperature of 2000 degrees Celsius. This is where a specially designed firewall came into place, because it prevents the hydrogen from spreading and makes sure that the pilot is protected at all times. With a special foam, carbon foam from seafoam, we created several samples which were produced and tested. Here you see a few of those samples, which were 0.5 meter by 0.5 meter and were tested together with boats. These tests took place at a temperature of about 1500 degrees Celsius and gave us really promising insights into our future designs. Bringing together safety and engineering is crucial in aviation. That is why, from the beginning of the project, we've been discussing our plans with the government. In this so-called design and certification plan, we describe how our modifications actually look like and how we can safely operate our aircraft. During our panel discussion, we further discussed what the importance of this is. Wow. In just 1 year of work, our full-scale engineering team achieved so much, even more than I could cover within this presentation, such as the development of a liquid hydrogen system. But let's look at our next steps. Upcoming year, the systems of the finished full scale will be tested and integrated into the aircraft, after which the aircraft will be ready for ground and flight testing. We are aiming for a gaseous hydrogen flight by 2023, after which we're going to replace the gaseous system, with a liquid hydrogen system. This system is already being developed, and this gives us 4 years to make it ready for a maiden flight on liquid hydrogen by the summer of 2025. However, as I mentioned to you in the beginning of the presentation, we need one important piece to the puzzle to start all of this, and that is a Sling 4 kit aircraft. I have some really exciting news to give to you, and I think I can best deliver that to you with the following video.
This airplane is empty weight about 500 kilograms and the load is 450 kilograms, which is exceptional for looking to other aircraft. We discussed together what the specifications should be. Should the aircraft fit regarding to your requirements? And it did. And we helped you to deliver the kit, which actually arrives today at Schiphol.
Thank you for your attention. Right now, there will be a small technical break of about 10 minutes, after which we're going to get started with our discussion panel. We see you right back after the break.
Welcome back.
Hello everyone, my name is Floris and today I will give you a virtual tour around our Phoenix full-scale airplane. I'm a propulsion engineer here at AeroDelft.
In mobility that is the safest worldwide was because of certification. And many people don't really know what certification is. So let's have a panel discussion with members here from the industry who know what it is and who can explain how it impacts our project and how it will impact the future of sustainable aviation. I would like to introduce our panel members here. Pieter Goskamp from the Ministry of Infrastructure and Water Management, Ode de Koning, full-scale certification engineer, Henry Wery, Dean of the Faculty of Aerospace Engineering at TU Delft, Rehan Siddiqui, certification engineer in the prototype engineering team, and Marijn Hogendoorn, R&D engineer at the Royal NLR. So I would like to give you a short schedule of what the certification panel will be about. So we'll quickly go through why these panelists work together with AeroDelft. Then we'll go through the experimental space in the Netherlands for experimenting with hydrogen aircraft, after which we'll look through what certification is. And at the end, we'll have a look at how education plays a role within certification. So I'd like to ask you the first question, Pieter. What does it mean for you to work with AeroDelft and us as a student team?
Well, on behalf of the Ministry of Infrastructure and Water Management, I'm part of the program team of the Sustainable Aviation Table. And the Sustainable Aviation Table comprises more than 30 entities within the Netherlands, operators, manufacturers, knowledge institutions, etc. And we have a goal to reduce carbon dioxide within the next decades. And for us, well, AeroDelft is not a direct member on the table, but we really strive the testing, experimenting and certification. And we encourage AeroDelft to be more innovative as you do, and therefore we'd like to work together.
Great, thank you very much. And Henry, for you, what does it mean? We've of course saw you already in the partner video, but we would like to hear from you what it means to work with such a student team as the Dean.
Yeah, like I said before, what I think is really extremely important that we actually start doing things. We have to show that things are possible. We have to try ways to make things better by thinking out of the box. This is essentially what you are doing. And of course, certification is a big issue. We are working on that at the university as well. I think we can help you there, but we are extremely proud seeing what you are doing. And we are extremely proud having you in our facilities at the university.
Thank you very much. And Marijn, for you personally, what does it mean for you to work with such a student team and with, for example, Rehan in such in-depth on the project?
Yeah, it's really great. I think we at NLR and also me personally, we've been together with AeroDelft really from the first steps when Liam came into the office of NLR with this idea of AeroDelft and Project Phoenix, and it's been amazing to be there throughout the whole way and to tackle these challenges together, the technical ones, but also the regulatory certification challenges that I think you both have to solve in order to really do what we want, and that is to get this testing, get this in practice, and just learn from there. So yeah, it's been amazing to do this with you.
Great, wonderful words to hear. And I forgot to say one thing. Please ask your questions if you have any in the chat, and I'll look through them here on my iPad, and if we see any cool questions, we'll ask them to our panelists. So let's start with the first question within our topics of the experimental space. And I'd like to ask that to you, Marijn. How have you experienced the experimental space within the Netherlands? So how has the Netherlands given you and the NLR space to test future aircraft in an experimental way?
Yeah, I think the answer to that question, a bit like how your project teams are given shape, is a bit twofold. On the one hand, you have the unmanned regime, where I think there is actually quite some experimental space, especially with the new EASA regulations that really look at the risks of your operation and more look at what is possible instead of what's not allowed. So I think in that area there is quite some experimental space, but I think the biggest gains are to be made in the next step of your project as well, the manned part, because there I think there's a real gap between the regulations that really focus on OEMs and making series productions of large aircraft, and right now there isn't the right climate for disruptors and startups or student teams like you to really start experimenting, because the rules are not proportional to what you want to do, and that's experiment.
Yeah, and I think that's exactly nailing the problem on its head. And Peter, you're of course from the government shaping these rules that we will have to use in order for this experimental space to be expanded. How would you look at this regulation change for the future? How do you see it develop?
Yeah, well, first of all, the innovations are increasingly speeding up the last years, and therefore on the inspection side and on the policy side, we really want to know, okay, what innovations are there within the next couple of years? So on both ends, inspection and policy, they have to prepare for it. And recently we've started a working group regarding testing, experimenting and certification on manned aviation. And we've been in touch with companies like AeroDelft, with AeroDelft and LAR, and other companies to see what are the upcoming tests and experiments. And we have seen there is a gap, like Marijn said, in the legislation at the moment. And the minister has said we want to be in the top group as the Netherlands for hybrid and electrical aviation. So we really want to fill out that gap. And during this investigation with the companies, we've seen what is needed, and we will definitely work on it as the ministry.
Yeah, I think for us that's great to hear that there's been a real work group in which we as a student team are involved and really see the progress put forth. And maybe Rehan, for you, it's interesting to hear and actually go back to the basics. Why does it take so long to build a plane compared to, for example, a boat or a car?
So that's a great question, thank you. First of all, of course, there are some challenges going from working in just a 2D space to a 3D space. So there are a lot more challenges we have in regards to that. But also, we're a brand new team. We started in September 2018. So then we don't really have previous designs to iterate on and to work with. It's a bit easier when you have proven design which you've already tested and you can make incremental changes on. But for us, we really need to get this right on the first try. If your car or boat stops working, you can move to the side of the road or be towed into the port. But for us, at best, our product becomes unusable in a hard landing, as we call it, or we end up damaging a building or something, and then we think that wouldn't do any favors to the industry and to this energy transition to hydrogen. So we really want to get this right on the first try, and we do our best to make all the design changes which we want to see. Like I think we saw in Sam's presentation that we've been working on changing the landing gear, but also our motor and propeller combinations. We've been making incremental changes to really make sure we get this right on the first try. Things can go wrong in testing, that's why you test, but we do our best to make sure we can do it as soon as possible. And in this final phase of integration and testing, we're really just dotting the I's and crossing the T's. So we'll see the first flight pretty soon, I think.
Yeah, great. It's very exciting to hear that. Of course, working behind the scenes, you see all of the problems, but then if you look from the outside in, it looks very smooth, but it's nice to shed a light on that and see where the challenges lie. And yeah, for Henry, you as a research institute as well, what does these kind of regulations hold for a research institute?
Yeah, actually, one of the worries that we have in order to really speed up the introduction of new technology, you see that the parameter space that we should test is expanding enormously. And what we fear is that when we have to wait until all these tests can be performed, it will take 30 years before you arrive at the point where you actually would like to be in 10 years from now. So that's the reason why one of our professors, René Alderliest, and he has been working on this topic for a long time, and he is working and in discussion with EASA as well, finding new methods to speed up the acceleration test, where you can use AI, but also deep knowledge of what's going on physically. And I think this is what we need, and this is something that we could use also together with you.
Yeah.
So I think there will be really a lot of cross-fertilization between what's going on in our faculty and what's going on in your team, and we are looking forward to that.
Yeah, and definitely that's also where you see that such partnerships come in very handy. If you have close ties with your partners, you can work on these systems together to better it as a whole. Maybe if we can move on to certification as a topic. Maybe a very funny question and very hard to answer for you, maybe Marijn. How long do you think it'll take before we see a hydrogen-powered general aviation aircraft to be fully tested, but then also fully certified? Because certification is something else than just having a plane that flies. For certification, you need to have a plane that can carry people legally and that the people also pay for it. That means a certified aircraft. How long do you think that'll take before we have a certified hydrogen general aviation aircraft?
Yeah, so first of all, I think that really depends on the last topic of the experimental space, because that really defines whether this certified hydrogen-powered aircraft needs to be certified according to rules that really aim for type certification. That's probably the area you want to go, but really now these first steps that we have to make together quickly is to find a set of rules that we define together, that we can all surely say that it's now safe to do this first testing and to start this experimentation phase. And I think that's the challenge to together, because it's all new, so all the rules have to be made new as well, to define these rules, like how can we achieve our one goal to keep aviation safe, and also our other goal to make aviation sustainable. And then really to your question on the timeline, I can only look at what others are saying. So you are aiming for 2025. Coincidentally, I think if you look at Zero Avia, they're aiming at 2024. If you look at Airbus Zero E, they're aiming at 2035. But yeah, then you're really talking bigger and type certification, mass production. So definitely in the next 5 to 10 years, I think we're going to see some really interesting things happening here.
Yeah, and I think for the general public, 5 years might sound as a long time, but for aviation, where aircraft are in the skies for more than 30 years, 5 years for new aircraft is very fast, and I think we're being very ambitious there. But that's what we need in this climate. Now, I've seen a nice question pop by here from Roelof Vos. His question goes, let's say we want to fly a 4,000 kilogram drone in the Netherlands in the shape of a V. Would that be possible in the foreseeable future? And whoever wants to answer that first. Maybe Peter?
Well, the only thing I can say regarding legislation on more heavy drones, I would say is that the process there goes via EASA and not via our national inspection. So therefore I cannot say anything regarding that one.
Okay, that's a very politically correct answer. Okay, well, thank you very much. And to Henry, do you think that that general aviation can be upscaled to civil aviation in the near future? Or how do you see general aviation in relation to that civil aviation sector?
I think it's going to be a stepping stone. The things that you can try, the things that you are working on, I'm convinced that there is going to be a lot of knowledge developed that can be used in bigger planes as well. Yep. So to some degree, the things you are doing are just scalable, in my opinion. So.
Yeah, so the drone could be used as like a stepping stone for the general aviation and then general aviation for civil.
Sure.
Yeah. Okay, that's great to hear. Another confirmation. We've hit the right nail, I think there. Yeah. And Peter, for you, maybe a general question. How do you see the developments of hydrogen in general aviation, just from a top view?
The roadmaps for general aviation are now being created within one of our action programs, and hydrogen is one of the topics, and we have to work on that. And therefore, for 1 or 2 years ago, it was not really on the agenda. So even not in Europe, and now also Europe and also larger manufacturers of engines are working towards hydrogen. So it's really important. So therefore we stimulate to develop on that.
Yeah, great. Okay, let's schedule over to the educational part of this whole certification space. And I think I can ask the first question to Ole best. And you came to AeroDelft without any knowledge about certification into a certification engineering role. What do you think this position did for your future career? How do you see this knowledge that you came up with this year impact your future career?
Yeah, so I think this year has been very valuable in the certification department for me. Because, and I think we'll zoom into this a little more later on, but it's not necessarily primarily discussed at the university certification. So yeah, I came here with little knowledge about certification and learned a lot. So I think one of the biggest takeaways for me this year has been that I got to see just how important certification is. Yeah, I think that'll help me in my career, because it has become clear that, you know, if you have a good idea for a new aircraft, some new type of aircraft, and you have a great execution of it without, you know, making it or getting it to comply to relevant regulations, you still have nothing. Yeah. So yeah, without the right certification, a good idea just stays a good idea, and I think that's been a very valuable insight. So yeah, I think it would be really worth it to, you know, get this into the curriculum at universities so that all students can, you know, obtain that knowledge.
Yeah, it's of course a very difficult topic, since it's difficult to do research within this field. Maybe it's nice to ask Henry, how would you want to incorporate certification in the curriculum, and how is it incorporated now? And also in relation to the research that's being done at the faculty.
Yeah, actually what you see is that right now we have it incorporated in our master program. So there is for a group of students the possibility to take part in the building an aircraft program, where we bought a kit essentially, where students are building it together. Actually what you are doing is even a step further, since you are really introducing new technology. So what we are building is indeed building a kit, starting with sheet metal, but right now you have to put in new technology as well. And I think the university, the students will benefit from this, and vice versa. So I clearly see a role for your program in our curriculum as well. And we have to talk to our director of education to see how we can fit it in, and perhaps that students can get study credits for this.
I guess
to be decided. So.
And how does that sound to you, Ole, as a student? You're of course a bachelor student. You're going to go into your masters, but for you, how does that feel?
Yeah, it sounds really good. Yeah, I'm still a bachelor student, so I didn't know about the master program, but I think it's really good because you know, yeah, there needs to be education for it, because with, you know, modern problems like the climate crisis, you'll get, of course you'll need new technologies, but also new regulations to go along with those technologies. So it is very important that we have growth in that sector, and yeah, I think education is the way to start that.
Yeah, the challenge is how to put new things in. As you certainly know, our curriculum is quite full. I dare to say that we have one of the most demanding courses or programs that exist anywhere, and I know you all have to work so hard. So we have to see how do we fit in new things and what can we leave out. But you're completely right.
And for you, Peter, I've heard this from one of your colleagues. 25 years ago, there were a lot of certification experts, of course, in the Netherlands. And because Fokker, the big company, quit their endeavors for the most part here in the Netherlands, most of these experts have actually retired. How could we build that knowledge back? How do you think that will take shape?
I think one of the things we can do is have more interaction with the companies, with the knowledge institutions, to see what's the latest knowledge, to get experience, to get some internships, both ways, to understand what's needed, and they must be on top of the level. So I think it's experienced by having worked, but also maybe fresh students with the new curriculum that knows and understand how to do things in a different way. It has to be safe, but technology is changing more rapidly, so I think the certification process has to adapt to that.
Yeah, definitely. I completely agree. And for you at the NLR, from the industry, of course, you're also a research-based foundation, but you do a lot for the industry as well. How would the NLR actually benefit from certification-related content in education?
I don't know if the question should be how it would benefit the NLR. Like we consider ourselves, at least in my department, experts on this topic. So if everyone coming from aerospace engineering is an expert, maybe we lose our edge. But I'm not very afraid of that. No, I think the most important part is that if this is taught more in the curriculum, and Henry, I have a colleague that would probably be happy to offer some lectures or guest lectures on this topic. I think what it would benefit the students or all of you is that, as you say, you really learn how to incorporate this into getting something to actually fly. But it also teaches you skills that help you even if you go outside of the field of aviation, because it challenges you that you have this new technology that doesn't have rules yet, and it challenges you to set those rules yourself and to, at the same time, think about how you're going to show that you comply to these rules. And doing risk analyses, that's just basic skills that will help you anywhere in your career, even if you go away from aviation or you don't work exactly on this topic. It's just essential skills to have, and that would benefit us also if students coming from university have those. Yeah,
definitely. I think that's also a testament to what Ole just mentioned about his experience here and then how that will impact his career.
I think one of the really important things which helped us when we were just starting off as a new team as well was one of these short courses which was offered by the NLR to our old teams as well, which really, at least for certification, helped us get going and really understand what we were missing or what gaps we were missing and how to really make a plan of attack or plan of approach to, how do we get this thing flying?
Yeah, definitely. Okay, well, I would like to give you the opportunity for some closing words on how you've experienced this day, this event, and how you look at the future for your collaboration with AeroDelft. Maybe Peter, you want to start?
Yeah, well, first of all, congratulations with all the achievements you've made the last 3 years, and working on the Sustainable Aviation Table. It's a lot of meetings, last year online, and now being here with your scale model and the video of the receival of the kit. It's really nice to work with you in the future as well.
Great, thank you very much. And Henry, for you?
Yeah, actually seeing what's happening right now really should make you proud. I think what is also a very great achievement, and this, talking about what can we do in the Netherlands. Did we lose a lot of knowledge? Well, I think there still is a whole lot. Let's face it, looking at our faculty, it's one of the largest in the world of aerospace engineering. But apart from that, what you are doing in your team, and I think this is really great, you look outside of your boundaries, you look outside of one faculty, you look at more faculties, you even look outside of the university, and that's what we have to do. Look not only from inside, but see what kind of knowledge you can get from other fields. Yeah. And this is what you're doing, and then you can really accelerate. And that's exactly what I see you doing, and that should make you so proud.
Great words, thank you very much. And Marijn, for you?
Along with what the others said, what you've achieved this year and the years before is really incredible. It's really a shame that we didn't have the first battery-powered flight of the aircraft this summer, but we will do it right after this summer. But it would have been a great end of your year of hard work. But I think it's really special how you bring everything together, this new technology, but also the fact that we're sitting here with you as students and the government, the universities and industry together talking about these topics. I think that just shows, that's something really special that you put together.
Thanks very much. And for you, Reon, if you look back at this event and then you're almost 1.5 years, I guess, in the team, how do you look back?
It was a great experience starting from, we didn't even have the molds when we started out, and then to have this lovely model here almost ready for scaled flight testing in just 2 years, I think it's been an amazing experience, and definitely learning a lot together with the industry, and then working together with ILT, INW, with the university, of course. You learn a lot, and I think it's definitely been a great experience.
Great, great. And Olo, for you, from the full-scale side of things, maybe?
Yeah, no, for us it's been a great year as well. You know, as we already discussed, you started without any knowledge on certification. And then, yeah, we're very close to handing in the design and certification plan right now. So that will be in a couple of months. And then, yeah, the certification process can really get started for full scale.
Yeah, great, great. Great to hear. And now we will have a short break. And, oh no, actually, we're not going to have a short break. We're going to have the video playing. And I hope you enjoy that video. Thank you very much.
Hello everyone, my name is Floris and today I will be giving you a virtual tour around our Phoenix full-scale airplane. I'm a propulsion engineer here at AeroDelft and I will be narrating the tour behind the computer to the left of your screen. And Alex, my colleague, will be having the VR glasses on him and he will be experiencing the tour himself.
Very cool, thank you. Yeah, I'm Alex and I actually work in operations in AeroDelft. So this is not my specialty, so I will guide it by Floris and looking forward to that.
All right, Alex.
Oh.
Okay. So what we can see here when you look at the screen is already the full-scale airplane, and we have some of the cowling of the nose already removed. So the airplane you're looking at is the Sling 4 that we got sponsored to us by Frisian Air.
I can maybe show it in a full. 1 second.
Oh.
Nope, that's not what I wanted.
Yeah, you probably have to go to some of the render modes before we can
go back to the
see the original again.
All
cool,
right.
so here it is. All right, so the Sling 4 is a 4-seater aircraft by its original configuration. What we are doing, we are converting it to a 2-seater aircraft that will run on hydrogen. So today, me and Alex will show you a bit on how the current configuration looks like and what components are inside the actual aircraft. All right, Alex, if you want, we will start at the very front of the airplane, just behind the propellers. This is the location where in the original airplane the combustion engine is located. Which we of course don't need because we will use a fuel cell. So we have replaced it with some other components, which you will see in just a bit. All right,
here we
cool.
go.
So let's move a bit closer so we can all take a good look at the components inside. And the first thing you will probably see is the electromotors, electric motors just behind the propeller. Of course, the fuel cell generates electricity. And we use that to drive these electric motors and to make sure that we have a good performance of the aircraft. And you can also see that there are actually 2 of them. These are electric motors delivered by Saluki, one of our partners, and they are joined together with a twin assembly, as we call it. And also you can see just behind and underneath the electric motor are some black and white boxes. And these are actually the batteries of aircraft. Our aircraft needs these batteries for a little bit of an extra power during takeoff and sometimes to taxi or just when we need some power that's not coming from the fuel cell. So we have 2 batteries and just in front of it is a DC-DC converter and basically it makes sure that the batteries can be used together with the fuel cell. All right, so there's also some red stuff you probably see inside the nose of the aircraft. This is the frame that's used to mount the motor to the firewall, to the main structure of our aircraft, together with all of the other components that are inside the nose. So what are these other components? There's a lot of stuff just that's different from the batteries or the electric motors. We actually have the stuff that's needed for the air intake of our fuel cell, and that's what you can see is using the blue piping to drive the air from just behind the propeller to the air filter, which you can see on top there, the black cylinder, and then just behind there is a compressor, and it goes to an intercooler. Basically, these are all fancy components that we use to make sure that the air can be used inside the fuel cell itself. And the fuel cell is not located in the nose of the aircraft. You can already see that it's kind of crowded in the nose. There are a lot of components that we need in there. So we had to put the fuel cell somewhere else, and that's just behind the pilots. But before we go there, the last thing that you see, I almost forgot, is of course the orange piping. There's a lot of it, and basically what this is the low temperature cooling loop. And this makes sure that all the components inside the nose are cooled down and don't overheat, and it cools down the air coming into the radiator that you can see in the front.
Wow, that's already a lot of components.
Yeah, it's a lot.
Just in that small, comparably nose. Very cool.
All right, yeah. Alex, so are you ready to?
Yeah, I want to look at it a bit longer, but I think we have to move on at some point. So yeah, sure. Let's see what else we have in this airplane.
All right,
you
cool.
Want to go a bit to the back, or?
Yeah, if you can move a little bit to the just around the wings of the aircraft.
Yeah.
There's some other very interesting stuff there for us to take a look at.
Maybe I can go a bit higher.
So as I told already before, the fuel cell, it cannot fit inside the nose. We would love to have it inside the nose, but there's not enough room. So therefore, the best location to store the fuel cell is just behind the pilots. So if you can zoom in a bit and remove some of the fuselage, some of the aluminium or the framework of the aircraft, we can take a look at what's inside.
Sure. I'll be here.
Yeah. So just remove it piece by piece. All right. So there's already some very interesting stuff popping up right there. Yeah. Cool.
All right.
So what you see here, just in front of you, is the pressure vessel, or more commonly known as the tank. This is a conceptual version of the actual tank that will be inside our airplane. So we have two ways to store hydrogen, as was already explained. You can store it as a gaseous at 350 bars, or as a liquid hydrogen, which you need to cool down it a lot. And the one you see here is a gaseous pressure vessel. And it makes sure that our hydrogen is kept safe, and it will then be transported into the fuel cell, where it will be used to generate electricity. So you see two lines. If you hover a bit over it a bit, we can actually see it a bit better.
Like this?
Yeah, so you can see that there are two connections to the fuel cell. You have the blue lines and you have the green lines. And the green lines are what we call the fuel lines. So when these lines are open, it will transport the hydrogen from the tank to the fuel cell. And the other lines are the venting lines. And basically what venting is, and we'll come that towards the end of this tour, is when we don't want the hydrogen anymore inside our aircraft, once we want to get rid of it, we use these lines to very rapidly dispose the gas behind the aircraft. But that's, I will explain that in a bit more time. Let's first take a look at all the interesting components that are in front of the tank.
All right. Sure. Should I remove some more parts maybe?
Yeah.
So we can see a bit more.
Yeah, that's a good idea. Just start blasting them away. It's a lot of parts.
Maybe I can even remove this one.
Cool. All right. So you see, you see a lot of different colors here. So a lot of interesting components. And the most prominent one is, of course, the fuel cell, which you probably already have noticed. And that's the big white box in the middle. And all the components around it, they are there to support the fuel cell. The fuel cell is really the heart of our airplane. It's the thing that makes it fly, and the most important part to what we're doing here at AeroDelft. Nice. And around it are all kinds of components that we need to make sure the fuel cell operates properly. So if you see just in front of the fuel cell, it's a black box called the humidifier, and it actually makes sure that our fuel cell doesn't dry out, which is very important, otherwise the fuel cell will fail. And there's also another very interesting component that's between the pilots and the fuel cell. It's called the firewall. And it's,
that's the grey one.
Yeah, so the big grey plane you see, it's a firewall that is being made by AeroDelft members themselves and tested. And the reason we have it there is that if they're in a very emergency situation where we might have a leak or even a small fire inside the cabin, there's always a firewall there to make sure the pilots are completely protected and so that they can land the aircraft in due time. So that's a function of the big black wall you see there. And we have some other components as well. So just out of the tanks that we just talked about, there are some valves and a pressure regulator that makes sure the pressure of the hydrogen is so low that we can use it inside the fuel cell. And we also have some red piping. And the red piping is needed so we can cool down the fuel cell. So you already saw the orange piping we just talked about. It's to make sure the components in the nose are cool. And the red piping is to make sure the components inside the cabin are cool. So mainly the fuel cell. And if you can remove the floor, so the gray stuff that's just below the fuel cell. Yeah.
Here?
Yeah, and you can actually see that's a very interesting and complex configuration. And it leads the coolant to a radiator that's part of the wing. There's actually another floor down there. I think it's part, so yeah,
here?
Another gray stuff.
Remove more?
Yeah.
More?
Yeah, I think so. Yeah, so there you see it. And it's actually, there are some pumps down there and they pump the cooling fluid from the fuel cell and to the wings. Because we need to cool down so much heat from the fuel cell, we had to think of a very interesting solution. And if you remove some of the wing parts, preferably the middle, then you can actually see how we are integrating the radiators inside the wing of the aircraft. Yeah.
Here we
so
go.
that's basically what it looks like, and the coolant gets cooled down there by the air that's flowing over the wing itself, and after that it gets pumped back into the fuel cell.
Wow, that's really everything connected, huh?
Yeah, it's one big system, Alex. Is there anything you want to ask at this point? Some interesting thoughts that have popped up inside your head?
Can we go to the cockpit?
Oh, of course, yeah. You want to be the pilot for once?
I want to be the pilot. I'm not going to be the pilot in the real plane, so I want to be the pilot here.
This is your chance.
Nice.
So, unfortunately, not all the components are already inside the cockpit. Normally, it would be very cool to sit down inside the leather seats of the cockpit and to have the control panel in front of you as well as the steering wheels. But there are some details that we can see. And this is actually how the cockpits or the test pilots will sit when the Phoenix FS will take off for the first time.
Wow.
That's cool, right?
So cool. Not everything there that should be there in the end, but...
Yeah, exactly. And you can actually see already the two of the cables and also the piping for the air intake.
Exactly. I just said, the piping. As you said, everything is one big system, not different things. You see the blue piping, you see here the black cables that come from the nose, as we discussed in the beginning, and go back.
And of course, the power from the fuel cell needs to go to the electric motor in the nose, and that's why it's there.
That makes a lot of sense, yeah.
All right.
Wow.
So if you go back to the end of the aircraft, there's one last interesting thing I can show everyone. And you can actually see it already in the right side of your frame, just beneath the tail. Yeah, there you see it. So I talked about the venting at the beginning of this video. And venting is, as I just explained, when we don't want the hydrogen inside our aircraft anymore. So there are a couple of safe places to vent hydrogen outside in our aircraft. And because of the hydrogen is very flammable and can also explode, we need to make sure to do this at the safest place possible. And from our analysis, this turned out to be the safest place. So the hydrogen that leaves the aircraft, basically behind the tail, at the end of the aircraft, and any plume or flame that will possibly be ignited behind the aircraft won't damage any of the components, any of the critical components There are of course some challenges. If there is a flame present here just behind the aircraft, a very hot flame, because hydrogen flames are very hot. We need to protect the tail, of course, but we are already searching for some answers on how to do this and how to best solve these problems.
All right.
So yeah, maybe Alex, you want to take it for a last spin around the aircraft so people
Sure,
can...
sure. I can maybe also move the power spec so you can see the whole thing.
Yeah, I think that's it.
I think as well. All right.
Oh, it's great like this. I think it's cool.
Now it's good.
So now you see the beautiful aircraft.
Yeah.
We can't wait to show it to you guys in real life. It's going to be even better
So
than
nice.
just a 3D model, and we hope we can do that in the near future.
What do you mean with just a 3D model? It looks very nice. You see all the parts. Sure, it's not the same as a real plane, and we can't wait for that, but I think that's great work here. That looks so cool. You can really see how it's supposed to be one day. You can see where all the work, all the work that has been done.
Yeah.
So really cool, really nice model.
All right, thank you, Alex, for joining me on this tour. Thank you all for listening to me, and I hope you have a great day.
Thank you, Floris. Really nice tour, really nice to see that plane. Can't wait to see it in real life.
I hope you enjoyed that video that Alex and Floris made together and actually took you through the whole full-scale aircraft and all of its components. I hope you learned a bit about how the system works and how intricate actually all these components fit together within actually a pretty small form factor. Of course, we had to take out these 2 seats in the back, and maybe at the start of the presentation you thought, why would you take out 2 seats in a 4-seat airplane? Well, this is why, because otherwise you won't be able to fit any of the systems in there. So I hope that gave a great insight. And as Matthew also mentioned, it's an enormous achievement that we've been able to acquire the aircraft, and that's all thanks to these full-scale engineers here today that have been working tirelessly to get this aircraft ready and all of its system design ready. And it's so cool to see how a year ago we did all of the interviews for the full-scale engineering applicants, and we selected, of course, the most ambitious and the most motivated students to work on these projects. But then a year later to see how this work, all of their work has transpired into real progress, honestly, that's an achievement of itself, and something that is very rare, I would say. I've seen the companies on the other side of a Zoom screen, someone starting out the meeting being very bored, and then the full-scale engineers start talking, and you see them light up and become inspired by the work they've done. But of course, all of the full-scale would not be anything without the foreknowledge of the prototype engineers and all of the work that's been done then. I want to highlight all of the prototype engineers some have already been working more than 2 years on this project, have put in tireless work, and at the start of this presentation, I think I understated the amount of effort and the amount of challenges that we faced. I think some of the engineers can attest to that. But nonetheless, we've persevered and we've been able to put this progress on the table, and I think that's a big achievement to us all. And now a department that is often forgotten in these kinds of presentations, because the engineers, of course, make progress and they have results that you can show. But we all know that us engineers, we're not that good at communicating our progress in a meaningful and an understandable way. And that's why we also have a twofold mission. We want to prove on one side, but also promote on the other side liquid hydrogen as an alternative fuel. And without our operations department, without you guys actually showing our progress to the outside world, we would be nowhere. And our small events department, just 2 people set up this whole event here today. It's a huge achievement on its own. And without our exposure trio actually making the exposure for all of our progress, we would have nowhere near the reach we have today. And the partnerships department working together with the management, but also with the engineers to get all of the funds in and all of the partners together around the table 24/7, I think is really a great achievement. And for graphics, even looking at this slide was made by graphics, and all of the graphical representations you've seen before, the renders, the communication material was made by these 2 people. which is awesome of itself. And that concludes our event here today. I hope you enjoyed all of the progress that we've presented today. And as a last tribute to you guys, all of the team members, I would like to welcome you up here to the stage. Come join me, and we'll end this year off with a bang. Yes? Are we done?
We're all been tested.
Great. I think we can close it. Thanks. Nice, guys.